Hey, hi to everyone. MAMSE School of Engineering, Department of Mechanical Engineering, online classes, subject Mechatronics, unit number 3. So last class we discussed with the stepper motor and the traffic light controller using 8085. Okay. So in most of the cases, we are using ADC and DAC for getting the data and return back the data from the microprocessor to the microprocessor. Okay, so now in this class we are going to discuss about the ADC and DAC. Okay, that is, so what is ADC? So what are the features of ADC and DAC in market? Then ADC architecture. Okay, like that we are going to discuss in this class. Okay. Okay, first we will see the ADC, that is interfacing analog to digital converter. So the aim of study is about 8-bit and 12-bit analog digital converter and the interfacing with 8085. In most of the cases, the PIO 825 is used for interfacing the analog and digital converter with the microprocessor. Okay, so this is the concept of ADC. That is, we are converting the analog value into digital. So in ADC, we have different kind of ADC models which was used in the conversions. In digital, we discussed, we studied like that. That is, we have more number of types of analog to digital converter. So flash type analog to digital converter, then successive approximation of ADC like that we discussed. Okay, in this topic, we are going to discuss about ADC 0808 or 0809. That is ADC 0808 means it is a 8-bit analog to digital converter which is worked with respect to the successive approximation type. Okay, successive approximation type. First, we need to know the what is successive approximation type. Okay, so in this first type, we have flash type, that is a direct comparator. Okay, we are comparing the given input analog signal with the prescribed analog signal. Okay, that means we are, if we are giving 2 volt, if input signal is 2 volt means we are generating the 2 volt or 2 kV with the different generators, then compare with the input signal. If the output is 0 means it will be considered as this voltage. If input is 2, the reference voltage is 2. If we compare means output will be 0. So if output 0 means the reference value equal to the input value. So like that we are find out in the given analog value using the digital signals. Okay, this is the concept used in the flash type, but in successive approximation type, so they have successive approximation register which is store the values. Okay, so what is the difference between flash and successive? So flash means if you are using 8-bit means you have to use 8 comparators and 823 decoder. If you want to if you want to get the values reference of 16-bit means you have to use 16 comparators. When bytes means bit means increasing means that it will be increasing the cost of the ICs. So cost will be increasing. So we are going for successive approximation type. So in this type, we can get the output of 8 clock pulses only. We will get the output of 8 clock pulses for any input. Okay, this is the concept. So successive approximation register having the same value. So that is successive approximation value produces some digital value. The digital value converted into the analog value. So that is compared with the comparator. Then it will analyze the data. This is the concept. Okay, here they have 8-channel analog multiplexer with the comparator. Okay, the SCR register will produce the data, that is digital to analog converter given to the register, then compare with the comparator. So that is start of conversion, then end of conversion, then output will be latched to the output latch. Okay, this is the concept of successive approximation. So this is the ADC IC. It is a 28-pin package. So with the input and output port, add a start conversion, end of conversion, clock, power supply, and ground like that they have. The address lines of analog input 07200 means digital 8-bit output data with 07 MSB and O0 LSB. SOC means start of conversion signal pin. EOC means end of conversion signal pin. Okay, OE means output latch enable pin if high enables output. So clock. So clock means clock input for ADC. Okay, so when VCC ground. Okay, here we have electric specifications of ADC, that is minimum SOC pulse with 100 nanoseconds. So minimum ALE pulse with 100 nanoseconds. Then clock frequency 10 to 1280 kilohertz. Conversion time 100 microsecond to 640 kilohertz. So resolution will be 8-bit. Then logical 1 input voltage maximum VCC minus 1.5 volt. Then logical 0 input voltage maximum 1.5 volt. These are the specification of ADC 08 and 08. Okay, this is the timing diagram of ADC, which was conversion process, that is clock, then start of conversion, then ALE. When ALE is enabled, then only the start of conversion will be enabled. Then end of conversion. Okay, after enable, Q enable, the output will be latched to the output.